welcome to you all in this course, Fluid Mechanics 1. In the last lecture, we discussed the course content and the lesson plan. In this first lecture about this course, we are going to discuss the fundamental concepts of fluid mechanics, basic properties of fluids, some special kinds of fluid, and different type of fluid flows. So course content I divided introduction, isotropic property of the fluid, some other basic properties of the fluid, and different type of flows. Now let us start. What is mechanics? So mechanics is a branch of science which concerned with the study of external influences such as force, heat inputs, etc. on some physical object. If that physical object is a deformable fluid, then the subject is said to be fluid mechanics. And if the deformable object is uh, solid, then it is the subject of solid mechanics. Now, the governing equations in fluid mechanics are uh, constitutive equations and field equations. So what are the field equations? Field equations, some physical laws which are same for all kind of fluids, like law of conservation of mass, law of conservation of momentum, law of conservation of energy, etc. So the equation representing those laws which are same for all kind of fluid are called the field equations, and some laws which are varying from material to material, and the equation representing those laws are called the constitutive equations. Okay, so fluid mechanics, it consists of both type of equations, field equations and constitutive equations. So constitutive equations are not same for same type of different type of fluids. It's varying from fluid to fluid. Now, in fluid mechanics, we shall apply the continuum hypothesis. There are two types of studies. One is called microscopic study and another one is called the macroscopic study. In microscopic study, we are considering the gap between the molecules, and the results find out by this study is very accurate. And microscopic study, we are not considering the gap between the molecules, but we are considering that the molecules are uniformly distributed over the whole object, and so the principle of limit continuity and differentiability is applied there. So in fluid mechanics, we shall consider the flows to be a continuum and we shall apply the continuum hypothesis. Now, one property of the fluid, that is the called isotropic property. So a fluid is said to be isotropic with respect to some characteristic property if that property is remain same in all directions at a point, or we can say that that property unchanged in all direction at a point. So such type of fluid is said to be isotropic fluid. A fluid is said to be anisotropic with respect to some property if that property will change in all direction at a point. So that kind of fluid is said to be anisotropic fluid. Now, incompressible and compressible fluid. So a fluid is said to be incompressible if its density will not change with respect to space or time, or we can say from one point to another point within an object, its density will not change at any instant of time. So such kind of fluid is said to be incompressible, while for the compressible fluid, the density will change from one point to another point within an instant. So we can say that a fluid is incompressible if density will not depend upon space and time, and a fluid is said to be compressible if its property, its density will depend upon space or time coordinates. Now, viscous and inviscid fluid. So, we observe that the fluid particle experiencing stress by the surrounding fluid particles, and these stress are of two types. One is acting in the tangential direction, while the another is working in the normal direction. The stress acting in the tangential direction is called shear stress, while the stress working in the normal direction is called the normal pressure or hydrostatic pressure. So viscous fluids are those fluids which are exerting both the shear stress as well as the hydrostatic pressure or normal stress, you can say. But inviscid fluid are those fluids which does not exert the shear stress, but it exerts the normal pressure at at the surface at any point. Now, viscosity. So, viscosity is a property of fluid which suppresses the flow rate. So, let us consider this figure. This figure consists of flow within a channel. So, there are two plates. One plate is here, where the velocity is u is equal to 0. One plate is at y is equal to 0. And suppose another plate is at y is equal to h. This plate is at y equal to h. And this lower plate is stationary while upper plate is moving with the velocity u. So the fluid is contact with the upper plate will also move with the same velocity u is equal to capital U, and while the fluid is in contact with the lower plate it will be remains stationary because fluid is stationary. Now suppose at any layer at y it's moving with velocity u, and another layer y plus dy its velocity will be u plus du, means from upper side to lower side its velocity is gradually decreasing due to the viscosity or viscous property of the fluid. So as change in the layer is dy, then velocity is changed by du. So velocity gradient you can say that is du by dy. So now we shall define law called Newton's law of viscosity. So this law states that the shear stress on a fluid element is directly proportional to the velocity gradient, that is tau is proportional to du by dy. We shall change into equality by multiplying a constant of proportionality, that is mu. So tau is equal to mu du by dy. So this mu is called the kinematic coefficient of viscosity. So tau is equal to mu du by dy. That is a mathematical expression for Newton's law of viscosity. Now Newtonian and non-Newtonian fluids. So the fluid which obey the Newton's law of viscosity is called Newtonian fluid, or in other way we can say if there is a linear relation between stress and rate of strain, then the fluid is said to be Newtonian fluid. So water, air are the example of such kind of fluid. The fluid which do not obey the Newton's law of viscosity are called non-Newtonian fluid, or we can say for fluids for which there is a non-linear relation between stress and rate of strain. Such fluids are called non-Newtonian fluids. So example of such kind of fluids are syrup, honey, charcoal, etc. Now we shall discuss real and ideal fluids. So real fluids are viscous and compressible, while ideal fluids are inviscid and incompressible. So for ideal fluid, at the surface of contact with the solid, uh, fluid have relative velocity along the tangential direction. The normal velocity must be zero at the surface of contact. So this condition is coming from the boundary conditions to be satisfied at the surface. Boundary condition at the surface is telling that the fluid in contact with the surface having same velocity as that of the fluid. Okay, so this condition is coming from there. Now some important type of flows: laminar flow and turbulent flow. So laminar flow, a flow is said to be laminar in which fluid particles trace out a definite path, and the path traced out by two fluid particles do not intersect each other. So such situation arises in the laboratory conditions where the path traced out by two fluid particles do not intersect each other. While in turbulent flow, the fluid particle do not trace out a definite path. It will trace out a zigzag path, and the path traced out by them will intersect. So wherever the fluid flow we are looking here in canal, or that rain water flow, or we can say the flow coming in tap, these all are the examples of turbulent flows. Now we shall discuss steady and unsteady flow. So a flow in which property of moving fluid is independent of time is known as steady flow. So the fluid property, if it is not depending upon the time, then such kind of flow is said to be steady, while in another kind of flow where the fluid property will depend upon the time, such kind of flow is said to be unsteady or transient flow. Uniform and non-uniform flow. So a flow is said to be uniform If the velocity is equal at every cross section of a channel or pipe, suppose the fluid is flowing within a channel or pipe, so the fluid having velocity equal at every cross section, then it is said to be uniform flow. And a flow is said to be non-uniform if the fluid velocity is different at each cross section of channel or pipe. So such kind of flow is said to be non-uniform flow. So these are few basic properties I discussed in this lecture. So again, I am recapitulating. In this lecture, we discussed the basic concepts of fluid mechanics. We discussed some basic properties of fluids, different type of fluids, and some important type of flows. So in the next lecture, we shall discuss some important vector calculus identities, some vector integral theorems, and then we shall discuss about the orthogonal curvilinear coordinates. Thank you very much for attending this.